Start the recording, then I'll convey. So, in today's session, we will be working on, or we will be looking at the Hadoop architecture, at least the jargons of Hadoop architecture. And I would like to convey about the file formats available. Then I would enter into the architecture part of Hadoop. Right, that's the plan. And before I go there, whoever didn't get the Linux or Python videos, can you just confirm me your consultancy name and your contact, please, so that I will get in touch with them. Right? Just ping me. Whoever didn't get Linux, just ping me so that I will talk to them. Yep. Okay. Fine. So meanwhile, you can ping. I'll get started. Like I told, today's discussion would be majorly on Hadoop architecture. But before I go there, I would like to I would like to convey uh, about the file formats. I mean, types of data available. So that fulfills a majority of the prerequisites, so that I can happily enter into the architecture part. So there are basically three types of data. One is structured, which most of you are aware of. Another thing is semi-structured. Third thing is unstructured. Uh, these are the file formats available. I mean, these are the types of data available, I should say, rather than file formats. These are the types of data available. So I'll just give you an example for each one of this in a practical scenario, so that you would understand what kind of data can you expect to deal with when you go to real time, right? So one second. Okay. So structured data. What is structured data? As the name signifies, if your data is properly organized in a very structured format, that is called structured data. For example, take any RDBMS data, take any RDBMS for that matter. RDBMS will have a database. On top of that, you'll have schemas. On top of that, you'll have tables. On top of tables, you'll have columns. On top of columns, you'll have your actual data, right? So your data is entirely organized, isn't it? So when you're talking about when you're talking about RDBMS, the first thing that comes to my mind is structured data. Everything is properly organized. Not only that, for example, take a table in RDBMS. I have a table probably which I've created with 10 columns, column 1, column 2 till column 10. And what happens here is, when I have 10 columns, when I'm trying to load data to that particular table, every day I have to load only 10 columns. I cannot go with 12 columns one day. I cannot go with 20 columns another day. I mean, whatever columns I've created, only I have to go with those columns. If at all I have to add new columns, what am I supposed to do? I'm supposed to I'm supposed to alter my table and add the columns. That means your RDBMS table is constrained to have only those many number of columns which you have created at the first point. So that's about structured data. Structured data is something that is having uniform columns, and that is something in a hierarchical way. I mean, hierarchical way in the sense, like I already told you, you have tables, you have columns, you have actual data. So this is something very perfectly organized. So that's about such structured data, which you guys may be already aware of. No? Then comes to semi-structured data. For semi-structured, let me open an Excel file. Okay, now comes semi-structured. When it comes to semi-structured data, what that comes into my mind is I have a table again, and I have created column 1, column 2, column 3. This is what I've done at the first day. Day 1 looks something like this, but day 2 I can have column 1, column 3, column 4, column 5, something like this. On day 3, I might load column 3, column 4, column 5, and column 6. So there is no perfect standard that every day that you have to load only so and so columns. You might load new columns, you might load existing columns. It all depends on how you are getting the data. That is called semi-structured data. I mean, part of your data is structured, part of your data is not. I mean, that's an textbook example for semi-structured data, but the real-time example that I can give is this. Today I have some number of columns. Tomorrow I can totally have a new column along with the existing columns. So this is called semi-structured data, right? But you can ask me, hey, when you are getting the new columns, how do you handle that? I mean, the perfect example that can hold semi-structured data is HBase. HBase is the perfect example which can hold semi-structured data because it can create the columns on the fly. It is not refrained. It is not refrained to load any new columns on daily basis. It can create, for example, on day 1 you have loaded these 3 columns. On day 2, all of a sudden I can get some 20 new columns. HBase can create them on the fly because columns are something that you create while loading the data, and based on what you're doing on daily basis, you might get new columns added, and you can load that into the table. HBase can do so. Or if you can give, if you want me to give some real time, or sorry, if you want to give some generic example, look at emails. Okay, look at emails in your Outlook. When you look at emails, the first thing that you will understand is who has sent the email, to whom it has been sent. To and fro is something that you can easily understand. But when it comes to contents in mail 1 would be something, mail 2 would be something else, mail 3 would be something different. So the contents are something that are differing from mail to email. Mail to mail, the contents are totally different. So that's what your semi-structured data is. Your data keeps on changing, or your emails are. I mean, in that example, part of your data is structured, and other part of your data is totally unstructured. That's again another example of semi-structured data. So semi-structured data, you can create columns on the fly. Semi-structured data, you can also take part of your data is structured and part of your data is unstructured. That's a classical example for semi-structured data. And finally, unstructured. Unstructured, I can give you lot many examples. For example, take a log file, a log emitted by a database, right? It's purely unstructured because it from one line to another line, if you compare, I mean, it totally differs. So you cannot compare that. So the problem here is in unstructured, you cannot predict anything. In order to predict something from unstructured data, you have to structurize that. You have to structurize your unstructured data. So that's what it all means. Unstructured data is a data which doesn't have any proper format. You take audio files, you take video files, you take image files, you take log files. All these are examples of unstructured data. say audio files or video files or image files, take any image, right? And you take any image to your file system, you know, do a cat of an image. When you do so, what happens is the format you get is totally unpredictable because it's in binary format. So all the binary formats are unstructured data. Let me show you an example here. Let me enter into the cluster. I think yeah, I'll go to this directory called images. Any image for that matter. I'll just copy this to my desktop. So this is a smiley, right? Because I'm able to view it using some image viewer. I'm able to tell it's a smiley. Okay, same thing. I will do a cat. See what you got? It's a purely a binary format. That's why I call the audio files, video files, image files, all these are unstructured data. I mean, though in your real time you may not have to work on image analytics or audio or video analytics, that's fine. I mean, but unstructured data can be a log file or any file which doesn't have any proper format, which needs to be structurized, comes under unstructured data. Okay, so these are the classical examples of structured, semi-structured, and unstructured. Any questions on this before I proceed further? Yes, Mukul, go ahead. Yeah, can we say XML files as semi-structured data? Yes, XMLs are semi-structured data as long as they are nested. For example, if you take a plain XML file, then I will call it as an structured XML. But when it is nested, probably two layers or three layers, which you cannot imagine or you cannot predict, that is an semi-structured data. Yes. Okay. Yeah, that's it, right? I mean, yes. Okay. Uh, Another thing, can you explain what exactly is HBase? Yeah. Anyways, HBase is a NoSQL database, which which we are going to learn in our future sessions. HBase is an NoSQL database, which is going to handle semi-structured data. When I say semi-structured data, wherein you have certain number of columns on one day and you have other set of columns on the other day, which I've already explained. Can you tell why image file is an unstructured data? Any binary format which cannot be analyzed straightforward is called unstructured data, right? Can I directly analyze what could be if I wanted to analyze some internal aspects of an image, for example, if I wanted to analyze something like how much of intensity that image has, how much of probably pixels that image has, I have to analyze it internally. So in order to do so, I have to do some algorithm on top of it. But that couldn't be a straightforward. I have to analyze some binary format, and that binary format you can classify it as unstructured data, right, Siddharth? In semi-structured data, how can we add column? Probably, we need not do any alter as such, Lakshmi, but in HBase, you need not write any alter command because HBase handles columns creation on the fly. Based on the file that you are loading on a particular day, based on that HBase creates the columns. Right? We need not tell HBase how to create the columns. It verifies or validates your file, whatever you're trying to load. Based on that, it creates the columns. I hope you got it, Lakshmi. And I see a few more hands raised. LT, I would request you to join the audio because I don't have an option to unmute you unless and until you join the audio, LT. And Lakan, please go ahead, please.
So what is a CAD of an image? Is it just like displaying the binary format of the data?
Yeah. CAD is nothing but to display the contents, and it can display the binary contents.
Okay, and the second question is like if you work for a client and if you get a data to analyze from the client, so be able to recognize the type of data by just looking at it, or like do you have any process to recognize the data?
No, you recognize it by looking at it itself directly. I mean, because when it is properly organized, it is structured. If it is something that is vibrating, I mean, if it is misleading, like if your client had told, hey, this is not the conformed structure. These are the columns you have. Tomorrow you might have got you might get some other columns. If he says so, that is semi-structured. If you look at in a jumbled way, I mean, there is no proper format at all. It is zigzag, if I say. That is unstructured data. I mean, you will recognize it looking at the file itself.
Alright, thank you, sir.
Yeah, no problem. No, LD, I cannot unmute you until you join the audio. And Syed, please go ahead, sir.
So when talking about unstructured data, structured and semi-structured, the file formats, they would probably be like, are there a certain amount of file formats that we'll probably see? Like, for example, like a text input format or key value text input format or sequence file input format. Are all these semi-structured or unstructured, or?
See, it all depends upon your file format once again. See, if I let me give an example. If I look at text format, right? It's a format of your data, but it doesn't talk about type of your data. In what format are you storing differs from type of your data. Text format can store structured, semi-structured, and unstructured. Similarly, if you look at sequence file, sequence is what? It's a key values. Key values in the format of binary. So that I can again coin it as structured data. But again, if that key values, if values are again a plain text which I have to analyze, so again that could come under semi-structured or unstructured data. So based on file format, you cannot come up with the type of the data, because format is something that you're doing so because you wanted to have better processing on top of it. So I cannot go with the type of the data based on the format of the data. Another example is Parquet file format, which is a very, very popular file format nowadays. Parquet is a binary format once again. It can hold structured, semi-structured, and unstructured. Right, Syed? I hope I've answered your question.
Yes, you have.
Cool. Yeah, finally, LD, you can post in your query.
Are you able to hear me?
Yes.
Okay. How would the data file, like a flat file, data files coming in the semi-structured, or?
No, like I told just now, right? I mean, I cannot see when you are getting a data file whether it is semi or unstructured or structured. It all depends upon the data inside the DAT file. You take a flat file or whatever you call it as, it all depends upon what data that file is holding. See, I can blindly call my DAT file as structured, or I can blindly call it as semi-structured or unstructured. But what that really matters is what data it internally contains. Right, LT?
Okay.
Yeah.
Yeah.
And Mukesh, yes?
Yeah. That was my question only. Yeah. You just gave answer.
Cool. Himanshu, is JSON semi-structured? Like I answered for XML, JSON can be structured or semi-structured. It all depends upon again how many. I would say, see, JSON can be structured, and sometimes when it is again nested JSON, I will call it as semi-structured. So again, I don't have a perfect answer for it. It can be structured and semi-structured. Okay, I think I've answered all your queries here. Finally, I'm entering into Hadoop architecture. I think the prerequisites that I've given so far would help you out in understanding the architecture better. So whatever we've discussed so far for the past 2 sessions or 2.5 sessions, I would say these are prerequisites which would help you out in understanding the architecture better. But before you go to the architecture, you have to understand the actual jargons of Hadoop architecture. So what could be the actual jargons of Hadoop architecture? So before I go there, let me tell you some brief note on Hadoop architecture. Hadoop basically has a master-slave architecture. You have masters, you have slaves. And slaves would be reporting to the master, masters would be guiding the slaves. I already told you a cluster. A cluster is group of nodes. Or if I have to tell it in a perfect way, cluster is group of racks, a rack is group of nodes. Those nodes I'm going to refer as data nodes going forward. Okay, so cluster is a group of rack is group of data nodes. So what is a data node? Data node, like I already conveyed, it's a physical machine which has some space and which has some processing capability, just like your CPU. Okay, it can contribute for both the space and processing. That's what I can coin it as data node. That's one thing. And these racks can be located in different physical locations, like you already told, right? To have the robustness or to have the business continuity, even if one rack goes down. That's all about distributing your nodes across the racks. Okay, that's fine. Now, these nodes are called data nodes, like I told, are slaves. So these slaves have to be guided by someone, which are called masters, right? I have three important masters in Hadoop 1.0 architecture. One is job tracker, another thing is name node, which is the main component in either 1.0 or 2.0 architecture. Name node is the master of your architecture. Okay, so and you have secondary name node. So you have job tracker, name node, secondary name node, which are the masters or Hadoop 1.0 architecture. And slaves are data nodes. On top of every data node, there is another slave called task tracker. Okay, on top of every data node, there is a slave called task tracker. Okay, now, so you understood what are the masters and what are the slaves. Now let's understand who reports to whom. You have data nodes who reports to the main master called name node. And you have task tracker who reports to another master called job tracker. And there is another component called secondary name node who reports to this. I'll convey it at a later point. But to give you on a high level, I told you the main master of this architecture is name node. And secondary name node is a backup, or I should say he is an standby of name node. Okay, so I'll talk more about secondary name node in our coming sessions. But for now, I will primarily concentrate on name node, data node, job tracker, and task tracker. Okay. Now you ask me. I've conveyed you that data nodes are something that will be stored in racks that could be distributed across different physical locations. That's what we have already discussed. On top of every data node, there could be a process running called task tracker, right? So what is the use of this task tracker? What is the use of job tracker? I'm going to convey that. But before that, you can ask me, hey, where are these masters are going to be located? Right? I told you data nodes are located in every physical location. On top of every data node, there will be a process running called task tracker. So I understood where the physical location of data nodes is. But how about the masters? Masters would be located in a separate rack, or it could also be located or distributed across the racks of your data nodes. Right? So it's simple. Name node could be in one of the rack, task tracker could be one of these racks, or name node and job tracker and secondary name node can be all together in a separate rack. It all depends upon how they are configuring it, right? So you understood the location of your masters. But now, for example, I have Himanshu. Himanshu wanted to log into his cluster. Will he log into name node? Will he log into job tracker? Or where will he log into? Will he log into data nodes? The place where Himanshu log in, or the nodes where Himanshu logs in, is called edge node. Okay. So what is this edge node? And why am I not showing this in the architecture? Because that's not part of architecture basically. It's one of the node dedicated for client logins, and there will be one node in every rack. Maybe if I say Himanshu is he's logging into rack 1. If I say Lakhan, he might be logging into rack 2. Maybe Lakshmi, she might be logging into rack 3. I mean, but when I say Himanshu or Lakhan or Lakshmi, when they are logging in to the nodes called edge nodes. They're neither logging into data node nor into the masters. They have a dedicated nodes called edge node, which is not part of the architecture. This is to facilitate the user login, and these edge nodes will be distributed across all the racks. Few users might be mapped to one edge node, few users might be mapped to another edge node. So it all depends on your load balancing, because all the clients cannot log into a single rack, right? When I say client, is nothing but the users basically. Okay, so there you go. I have a master slave architecture wherein the masters are name node, job tracker, and secondary name node. The slaves are data nodes and the task trackers. And you have, as I told, master slave architecture. These masters would be guiding the slaves. So name node would be guiding data nodes, and job tracker would be guiding the task tracker. We already know that. Now, if I have a task to be accomplished, it's the name node who decides who has to work on it, right? Should I give it to data node 1, 2, 3, or should I give it to 4, 5, 6, or should I give it to 8, 9, 10? That decision will be taken by name node. But how it takes, we are going to discuss that. But you have to understand that it's the name node who decides what has to be done and who has to do it. So that resource management or the decision capability will be there only with the name node. That's why I've told this is the heart of this architecture. So once the name node decides which data nodes has to work on a particular task, now those data nodes would be working on that task as instructed by the name node. When they are working, there will be something called task tracker on top of every data node, right? Or there will be a task tracker on top of every data node. When the data nodes are working on the task given by the name node, someone has to monitor it or someone has to track it. For example, I've given a work to Dhruv, Hamant, and Binoy, let's say. These are the three guys who are working on a task given to them. And I'm the name node who has given this three people to work on a task. But I cannot go and ask Binoy, hey, how much have you done? Similarly to Dhruv and Hamant. But someone has to keep a track on it. So there is a task tracker on top of Binoy, similarly on Dhruv and on Hamant. What this task tracker does is, it tracks the status of the task being accomplished by Dhruv, Hamant, and Binoy. So what it does, there is a task tracker on top of every data node, right? What they are going to do? They are going to report the status to the job tracker. So what would job tracker do? For a particular job, which is split among Binoy, Dhruv, and Hamant, job tracker is going to calculate the status of entire job basically. When I say this, for example, when I gave a job, when I have a job basically, that is split among three people, Binoy, Dhruv, and Hamant, right? So when I have this job of doing something which is split among three data nodes, they work on it, and their task trackers will report the status to the job tracker, and based on the status given by the task tracker, job tracker will calculate the status of the job. For example, Binoy had accomplished 30%, Dhruv had accomplished 40%, and Hamant had accomplished 20%. So 30 plus 40 plus 20. it would be somewhere around 70 plus 90 by 3. So the total job completed will be 30% because it's the cumulative percentage of Binoy, Dhruv and Hemant which contributes for the job, right? Because I have a single job which I've split among 3 people and they are working on it in a distributed way. But one job, one of the data node is working fast, or one of the data node has completed 40%, other data node has completed 30%, other has completed only 20%. So 40 plus 30 plus 20, which is 90, divided by 3, which gives me the total percentage of the job accomplished by all the data nodes. As simple as that. So that's the calculation that job tracker is going to do. So that's why task trackers do report to job tracker, right? You should have got clarity now. Of course, there are many more things on top of job tracker and task tracker and data nodes and name nodes, but this is just to give you a very high level overview, right? So that's about Hadoop architecture, a master slave architecture on a high level. But before I go into, before I take a deep dive, I have to convey you few jargons of this architecture. The first thing is block size. So what does this block size mean? Block size is nothing but the size of the blocks. For example, I have a data node and I say it has 1 GB of size. Of course, I understand this is a very small size, but still for our convenience, I'm saying that, okay, let me put it as 1 terabyte. 1 terabyte of size. When a data node of 1 terabyte is there, right? When one data node of 1 terabyte is there, what I'm going to do is, what Hadoop is going to do is, this 1 terabyte of space will be logically split into blocks. Blocks of 64 MB in few, by default I would say 64 MB. So what does that mean? That means this 1 terabyte will be treated as, 1 terabyte is what? 1024 GB, right? Into 1024 megabytes divided by 64 gives me 16,384 blocks. So if I have a data node of 1 terabyte, it's 1 terabyte space, but to Hadoop, it will be 16,384 blocks. One has to remember that. Okay, so your data or your hard disk is logically split into blocks. You can ask me, how is it going to do? It's simple. The memory address, when I say space or size, it will have memory address, right? That address will be mapped to blocks internally. But anyways, we don't bother about it. What we really bother is how many blocks will I have in my data node. So yeah, I spoke about a data node here. If I have a cluster of, let's say, 10 data nodes, right? Each of 10 terabytes, it would probably be something like 163,840. It's not, it's 0.1 million, right? Close to 0.16 million blocks. Okay, so this is what I was referring to. What happened? Okay, 10 into 1 terabyte here. So totally 10 terabytes of space. So 10 terabytes means what? For you, it is 10 terabytes, but for Hadoop, it's gonna be 0.16 blocks approximately. So why are they splitting or logically treating space as your blocks? It's simple. This is to achieve distribution. For example, if I want a file to be read, I wanted Dhruv, Hemant and Binoy to read that particular file. Okay? So what is the point of asking all these 3 people to read the same file? Rather, I would ask, if that file has 90 pages, I will ask Binoy to read first 30 pages, Dhruv to read next 30 pages, Hemant to read last 30 pages. So with this, I'm completing the reading of book in a distributed way. So that means I'm splitting my book. In order to split your file, the underlying file system who stores that file has to be distributed, right? So that's why Hadoop is treating the entire size of your data node as blocks of 64 MB or 128 MB, right? I mean, the latest block size by default, what you get is 128 MB, but you can modify it. You can change it to 256 MB or 512 MB. It all in the multiples of 64. You can tweak it. How to tweak it? We will learn that later when we are installing our cluster. But yes, this is the block size. And what is the significance of having block size is to have the distribution achieved. I hope I answered I hope all of you are clear with this. Next important thing would be, okay, let's read the definition. Default block size in Hadoop is 64 MB, but again, there would be a slight correction here. It could be 128 MB as well as per the latest Apache's configuration. Anyways, that is configurable. It could be 64, 128 or 256. In the multiples of 64, you can configure it. So why block size is required? I've already conveyed that. Now, heartbeat signal. That's again a very, very important property. To make name node aware of the status, active or inactive, of the data nodes, each data node send a heartbeat signal for every 3 seconds. I was always talking about Benoit, Dhruv and Hammond, right? 3 people reporting to me. But remember, I have only 3 people now. What if I have 300 people reporting to me, right? So would I go out to each and every person and ask, hey, are you up and running, or are you down for some reason? Are you sick for some reason? So it will be difficult for me, right? I cannot go and ask all these 3 people or 300 people. Rather, I would ask all the people reporting to me to send a heartbeat signal, a 0-byte file every 3 seconds. Hey, send me a file. If you don't send me a file for say 10 minutes, I would assume that you are down, you are sick. That means I will put you into the dead nodes, so that admins would intervene and check what could be the problem. That means the data nodes in a cluster has to send heartbeat signal for every 3 seconds to the name node. But what is the significance of sending heartbeat signal? The significance of sending heartbeat signal is to make name node aware that these data nodes are up and running. If they are not sending heartbeat signal for significant amount of time, name node will treat that data node as a dead node, and it will put that into dead nodes list. So what is the significance? What happens when we put you into a dead node list? Admins will come and check why this node has gone down. Maybe the reason could be there is a power shutdown, or maybe there is an port configurational issue, or maybe there could be some configurational issue. It could be any reason for that matter. Main reason would be power shutdown or power plug issue or something for a data node to go down. Anyways, that's an admin's headache. We need not bother about that. So because there will be plenty of data nodes and all this has to be monitored by the name node, it is asking the data nodes itself to send the heartbeat signal for every 3 seconds, just to make aware or just to make sure that these data nodes are up and running, right? I hope this is clear. Is there a master for edge nodes? Yes, I mean, those edge nodes also do report to name node, but still they don't work on anything, They don't process your data, they don't store your data, nothing. So, any questions, guys? I see Mukul has raised a hand, right? Yes, Mukul, go ahead, please.
Yeah, I have a couple of questions. First, in the earlier diagram, you told us about task tracker and data node. And so task tracker keeps track of
the task the data node is working.
Yeah. And in the previous slide, you told us that the data node sends signal to name node.
Yes, both are different, right? Tracking the status of the task and sending heartbeat signal are two different things. What is the significance of task tracking? That's to make sure how much percentage of job is done. For example, if I am asking 3 people to work on a task, how will I know whether they have completed the task or still they are working on it? That is different. How will I know whether they are up and running? That's a different thing. I will know that they are up and running only when they are sending me the heartbeat signal, right? Okay. And I will understand the percentage of job done only when I track the status of how much, like 10% or 20% or 30%. So these are two different things.
Okay. Yeah. And my second question is about block size. So in Hadoop 2.0, the block size is 128 MB. Am I right?
Absolutely, that's true. I mean, that's what I told, right? In latest Apache configuration, even in Hadoop 2.0, earlier it was 64 MB only. Now they've got, probably last 1 year, it is like 128 MB. The current default block size available in 2.0 is 128 MB. I agree with that.
Okay, so in 2.0, you cannot go lower than 128 MB, right?
No, that doesn't mean that you cannot tweak it. You can go to 64 MB as well.
Okay.
Right? You can configure it in the multiples of 64. You can go to 64. It can be 128. It could be 256, or it could be 512. It could be anything. In the multiples of 64. Okay. Default will be 128.
Okay, got it. Thank you.
Yeah. Any other questions, anyone? So whatever I'm explaining now is 1.0 architecture. That's true. So first of all, we'll discuss about 1.0 architecture, and then only we'll go to 2.0 architecture. But you can ask me, hey, why don't we go to 2.0 architecture directly? See, when there is 1.0 and 2.0, there is a delta part in 2.0. It's not that 2.0 is totally changed. It's the drawbacks in 1.0 that had been rectified in 2.0. So we will see what are the drawbacks in 1.0, then we'll go with 2.0, right? Okay. That's correct, Siddharth. 0-byte signal, 0-byte file is a heartbeat signal that will be sent from the data nodes to the name node, which is the heartbeat signal. See, this is simple. If there is one data node of 1 terabyte, this 1 terabyte will be calculated as blocks of 64 MB, which comes around 16,384. But in a cluster, if I have 10 data nodes, each of 1 terabyte, how many blocks do I have? It is 0.163840 million blocks, or 163840 blocks of data are available in a cluster of 10 data nodes of having each of 1 terabyte size. I hope this is clear to everyone. Yep. There are a few more hands raised. Let me check who are this. Yes, Lakan, please go ahead.
Hi, so I just posted a question here. So what do you mean by logically split and a physically split? Like, is it a memory allocation or something else?
See, good question, basically. When you have a database or when we have a hard disk, let's say you have an external hard disk. When you are going into your external hard disk and physically splitting each MB into a separate part, that's a physical split. Don't ask me how to do it. Even I don't know how do you work and split your databases. But logically means when I say space, you have an 1 terabyte space or something, what does that mean to you? It's an physical, it's an address, right? Address mapping will be there. For every byte, you will have a specific address. When you declare a variable, it is nothing but pointing to an address. Am I correct, Lakan?
Yeah.
So logical split means so and so, starting from so and so memory address till so and so memory address, let me treat it as one block. Right? I'll make a note of it. I'm not doing anything going into my database. Rather, I'm maintaining a notes saying that, hey, starting from this address to this address, I'll read it as one block. Starting from this to this, I'll read it as another block. That's what called as logical split. You're not going internal to your hard disk or something and splitting it. Rather, you're making a notes of which belongs to what. 1 second, please. I'm sorry, Lakan. I was talking. You got the answer, right, Lakan?
Yeah. So, but I have one more question here. Please. So task tracker monitors the data node, and also the data node sends heartbeat signal to the name node, right? So usually like, these are two different tasks. So the task tracker just check like how much percentage of the this is going on, and then the name node will check if the data node is working or not. That's it, right?
Yeah, that's correct.
So that 3 seconds of signal, is it by default or we can change it? So how does that? Is it by the architecture or something else?
Everything I quote here, the numerics, those are by default. You can tweak it, but if it is supposed to be tweaked, I will tell, hey, this is something that you will tweak it in your regular cluster, but 3 seconds, you will leave it as is. You don't change it basically.
Okay.
Yeah. Because see, if you increase that, the time that name node recognizes a particular data node has gone down will increase, which in turn causes problem for us. So that shouldn't be appreciated. So we will go with 3 seconds.
So 3 seconds is recommended. Okay.
Absolutely, that's correct.
Okay. Thank you, sir.
No problem. Yes, Manj. Himanshu, you wanted to ask something?
Yeah. So task tracker sends the percentage of each data node. Is it also at a frequency, or task node report in like, let's say 2 minutes or 60 seconds? Every 60 seconds they keep reporting the percentage.
Okay. So yeah, I will convey that basically when we install the cluster, because there is something called splits. There is a property called splits based on which job tracker will ask the task tracker to send the status, right? I mean, one job will have a different split, another job will have another split. So probably I'll answer this question at a little later point. But yes, there is an interval for every task when it's gonna send the percentage, but it's not for every 3 seconds or something.
Got it. And we can configure each data node to be at a different interval.
Not like that. Not like that. You can configure your job. For example, you are running a job. So at what frequency this particular percentage has to be updated, that you can configure, Himanshu.
Got it.
Yeah.
Got it. Thanks.
No problem. Any other questions? Oh yeah. LT, go ahead please. Good questions, but basically when people are asking me multiple questions, those are not dumb questions. They're good questions people are asking me. I appreciate that. Yeah. Go ahead, LT.
Yeah. The heartbeat signal is produced for 3 seconds. If the node is inactive, it will wait or it will pass to the next node.
See, what your question is, when you are saying 3 seconds heartbeat signal being sent by data node to name node, if that particular node is down, because if it is not sending a heartbeat signal, obviously he will go to some other data node by listing this data node as dead node.
Oh, okay. So that it won't send the next signal, correct? It won't send the next.
No, he is already dead, right? He will not send. I mean, if he's really dead, no point of again waiting for heartbeat signal from him. Got that?
Yeah, I got that one. But if it is again active, do you get any signal back or?
No, once it goes to dead node, right? Once it goes to dead node list, it has to be manually treated and it has to be activated. Once it is going to dead node, no one bothers about it. Whether it is sending, it doesn't send heartbeat signal. It's blocked.
Okay.
Yeah.
Okay. Yeah. Thank you.
No problem. See, okay, Money Raj, that's a good question once again. Who will be the first in hierarchy, name node or job tracker? I should say name node should be the hierarchical. I mean, he's the top. He's the I should say he's the king. But before I go to the king, I have to go to someone, right? An agent. That's nothing but job tracker. But the priority goes with name node, but I cannot go to name node directly. I'll have to first go to this guy called job tracker. From there, I'll go to the name node. So that's how it works. But the main person in your architecture is name node. To reach your to name node, you will go to job tracker. If node is dead, can we repair and join the process again from the beginning, or will there be backup? There will be backup for a process which is already running. For example, if a data node is running and it is already working on a task, if this data node is down, while working on a task, how this can be treated. Should I restart it from the beginning? I would say no. There will be a backup for it. That we will understand when we talk about replication process. And Hadoop does the logical separation, the data nodes into blocks, just to keep track of every minute amount of data. No start. It's not about tracking, it's about distribution. You are logically separating your data nodes into blocks because you wanted to store your data into multiple blocks because you wanted to achieve the distribution. That should answer your question, both Lakan and Siddharth. Right? So I'm giving you one more day to watch Linux, Python, and core Java, right? But the people who had not got the tutorials yet, I see only few people had pinged me. Just ping me your consultancy contact name and your consultancy person. Sorry, your consultancy name and your consultancy contact person, so that I can reach to them to give me a confirmation. Right? I hope you get the thing here. Whoever doesn't get the tutorials, please just ping me. I'll wait here for a couple of minutes. But whoever got the tutorials, I'm giving one more day. Starting from tomorrow, we will work on the case studies, right? I mean, both on Linux, Python, or at core Java, probably one for each consultancy. Yes, Himanshu, I'm aware about